9765. What is the difference between the Fowler flap system and split flap system? A. Fowler flaps produce the greatest change in pitching moment. B. Fowler flaps produce more drag. C. Split flaps cause the greatest change in twisting loads. The correct answer is A. The main difference between the Fowler flap system and the split flap system lies in their effects on the pitching moment of the aircraft. Fowler flaps are a type of high-lift device that extends both rearward and downward when deployed. This deployment increases the wing area and modifies the wing's shape, resulting in a significant change in the aircraft's pitching moment. The pitching moment refers to the rotational force around the aircraft's lateral axis, which affects the aircraft's stability and control. On the other hand, split flaps are a simpler type of high-lift device that rotate downward from the lower surface of the wing when deployed. While they provide additional lift, their effect on the pitching moment is relatively smaller compared to Fowler flaps. Therefore, the difference between the Fowler flap system and the split flap system is that Fowler flaps produce the greatest change in pitching moment, which can have a more significant impact on the aircraft's stability and control, while split flaps have a comparatively smaller effect on the pitching moment. 9766. On which type of wing are flaps most effective? A. Thin wing. B. Thick wing. C. Swept back wing. The correct answer is B. Flaps are most effective on thick wings. Flaps are high-lift devices that are used to increase the lift produced by an aircraft's wing during takeoff and landing. They work by increasing the wing area, modifying the wing's shape, and altering the flow patterns over the wing. In general, flaps are most effective on thick wings. Thick wings have a larger chord, the distance from the leading edge to the trailing edge, and a higher camber, curvature, compared to thin wings. These characteristics allow thick wings to generate more lift at lower speeds. When flaps are deployed on a thick wing, they further increase the wing's camber and surface area, resulting in a significant increase in lift. The thick wing structure can accommodate the additional surface area and camber provided by the flaps, leading to a more pronounced effect on lift enhancement. While flaps can be effective on various wing configurations, they tend to have the greatest impact on thick wings by significantly increasing lift and improving the aircraft's low-speed performance. 9771. When compared to plain flaps, split flaps? A. Produce more lift with less drag. B. Produce only slightly more lift, but much more drag. C. Enhance takeoff performance in high-density conditions. The correct answer is B. When compared to plain flaps, split flaps produce only slightly more lift, but generate significantly more drag. Split flaps are a type of high-lift device that extends downward from the lower surface of the wing when deployed. While they do provide some additional lift by increasing the wing area and modifying the airflow over the wing, the increase in lift is relatively modest compared to other types of flaps. However, split flaps generate a significant amount of drag when deployed. The downward extension of the flap creates a large surface area that interacts with the airflow, resulting in increased drag. This additional drag can be beneficial in certain situations, such as during landing, where it helps to reduce the aircraft's airspeed and facilitate a controlled descent. So, the primary difference between split flaps and plain flaps is that split flaps produce only slightly more lift but generate much more drag, which can be advantageous in specific flight scenarios. 8355. What is the ratio between the total load supported by the rotor disc and the gross weight of a helicopter in flight? A. Power loading. B. Load factor. C. Aspect ratio. The correct answer is B. The ratio between the total load supported by the rotor disc and the gross weight of a helicopter in flight is called the load factor. Load factor is a measure of the total aerodynamic forces acting on an aircraft, expressed as a ratio to its gross weight. Load factor represents the load or forces experienced by the helicopter's structure and rotor system during flight. It is calculated by dividing the total aerodynamic forces, which include lift, and other forces by the aircraft's gross weight. Load factor is commonly expressed as a multiple of the helicopter's weight. For example, a load factor of 1 represents the aircraft's weight, while a load factor of 2 represents twice the aircraft's weight. Load factor is an important consideration in helicopter design as it affects structural integrity, maneuverability, and the amount of lift required from the rotor system. Higher load factors increase the stresses on the helicopter's components and may require higher power settings from the engine to maintain stability and control. So, the ratio between the total load supported by the rotor disc and the gross weight of a helicopter in flight is referred to as the load factor. 8402. How should the pilot execute a pinnacle-type approach to a rooftop heliport in conditions of high wind and turbulence? A. Steeper than normal approach, maintaining the desired angle of descent with collective. B. Normal approach, maintaining a slower than normal rate of descent with cyclic. C. Shallow approach, maintaining a constant line of descent with cyclic. The correct answer is A. During a pinnacle approach, the pilot aims to land on a small and confined area, such as a rooftop heliport. In high wind and turbulence conditions, it is crucial to maintain precise control over the helicopter's vertical descent rate and ground track to ensure a safe landing. By executing a steeper than normal approach, the pilot can better control the vertical descent rate and manage the effects of wind and turbulence. This allows for a more controlled descent, reducing the risk of being affected by gusts or sudden changes in wind direction. Maintaining the desired angle of descent with collective control enables the pilot to control the helicopter's vertical speed effectively. The collective control adjusts the rotor blade pitch and lift, allowing the pilot to control the rate of descent during the approach. It's important to note that the specific approach technique may vary depending on the helicopter's characteristics, pilot experience, and the particular situation. However, in conditions of high wind and turbulence during a pinnacle-type approach, a steeper than normal approach with collective control is generally recommended for better control and safety.